before we start, before we start, I will show you some videos. Okay, so that's video is about whatever we, whatever we slides we have visited in the first session, computational thinking. So it's a kind of summarization thing. So I request all of you just see the video. Let me uh, just present that. Is my screen is visible to all of you? Just like,
Yes, sir.
okay, thank you, thank you. Okay, okay, just listen and see carefully.
Imagine you're asked to solve a complex problem. And to make things even more challenging, you cannot use the tools you normally use to help solve the problem. Sounds pretty difficult, right? Without a strategy, it certainly would be. Today, we are going to demonstrate a common process for solving complex problems known as computational thinking. Computational thinking is the thought process involved in formulating a problem and expressing its solution in such a way that a computer, human, or machine can effectively carry it out. Computational thinking involves 4 steps. Step 1 of the computational thinking process is decomposition. Decomposition involves breaking a complex problem down into smaller, more manageable parts. For example, take this math problem. Find the sum of all numbers between 1 and 200. How can we break this problem down into smaller equations? 1 plus 2 equals 3. 3 plus 4 equals 7. 5 plus 6 equals 11. 7 plus 8 equals 15. This is going to take forever, and it's really hard to keep track of in your head. There's got to be a better way. Let's try a different set of combinations. 200 plus 1 equals 201. 199 plus 2 equals 201. 198 plus 3 equals 201, etc. Step 2 of the computational thinking process is pattern recognition. Identifying patterns or trends within a problem. Let's return to the problem we started in step 1. Find the sum of all numbers between 1 and 200. What pattern do we see here? If we take the sum of the high number and the low number, we get 201. And all the other pairs have the same sum. We need to figure out how many times the 201 pattern repeats. You could count all the pairs, which would take a long time, or take the high number and just divide it by 2. 200 divided by 2 equals 100 pairs. If the sum of each pair is 201 and we have 100 pairs, we can now determine the sum of all numbers between 1 and 200. Step 3 of the computational thinking process is abstraction. Abstraction suggests we identify specific similarities and differences among similar problems to work toward a solution. In our original problem, we had to find the sum of all numbers between 1 and 200. Let's look for similarities and differences. All the pairs have the same sum, so we can get rid of these. Now, if we focus only on the important details, we see that we can express the problem as an equation. 200 plus 1 tells us the sum of each pair. 200 divided by 2 tells us the number of pairs. Multiply them together, and we find that the sum of all numbers between 1 and 200 is 20,100. The fourth and final step of the computational thinking process is algorithm design. Algorithm design involves developing step-by-step instructions for solving the problem, which you can use again to solve similar problems. In our original problem, we had to find the sum of all numbers between 1 and 200. Step 1. Find the sum of 200 plus 1. 200 plus 1 equals 201. Step 2. Find the quotient of 200 divided by 2. 200 divided by 2 equals 100. Step 3. Multiply the answers from step 1 and step 2 together. 201 times 100 equals 20,100. This algorithm can be used to find the sum of all numbers between 1 and any number. Let's see how it works with 1,000. Erase the 200s. Now find the sum of all numbers between 1 and 1,000. 1,000 plus 1. 1,000 divided by 2. Multiply them together, and we end up with 500,500. Computational thinking can be used to solve problems that may previously have seemed impossible to solve. It is a powerful skill. You can use it for life.
So I think it's I mean understandable to all of you. It's very simple steps about computational thinking mentioned in the video, and the similar thing we have explored in our first session. Like if we are also trying to do some kind of thinking and find out some steps and try to solve some kind of puzzles, and try to find out some kind of patterns within that. So these are, these are the steps. In the first slide also, I have seen that in the computation thinking, there are few steps are there. Okay, like a decomposition, pattern recognition, abstractions, and then algorithm. So these are the four important steps of any computational thinking problem. If you given somebody to students only need to learn how to i mean mm, how to conceptualize the problem, and in a step by step manner. Okay, so is the video is understandable to all of you? Have you seen that video? Is it okay? Yeah, to the participants, is it okay? You can, are you understandable? As a
Yes, sir.
Yes. Okay. So anyway, just move forward. I'm just sharing my screen again to share my presentation. Okay. For the next session. Okay. Okay. Is my screen is visible?
Yes, sir.
Yes.
Okay. Okay. So again, we are coming back, and we will again we will try some more interesting puzzle